This is 11.1 homework number 1, simplifying rational expressions. This is video number 2 for the homework examples. So the first homework example we're going to do is where we have a monomial in the numerator and a monomial in the denominator. So this is a monomial and this is a monomial. So what we're going to do is notice that we have a coefficient 30 in the numerator and a coefficient 35 in the denominator. So I'm going to write 30 over 35 times, and now I'm going to write the like variable terms as a fraction. Just kind of splitting it up a little bit just so you can simplify a little bit easier. You don't have to do this. If you want to just simplify it in one fraction, that's fine. But for my notes and my teaching, I'm just going to separate it out. So 30 over 35. So to simplify that, we divide both the numerator and the denominator by the greatest common factor, which would be 5. So that we get 6 over 7. Now for our variables, we have x to the 4th over x to the 10th. So what I'm going to do is, there's several different ways we can look at this. We can remember that we subtract top minus bottom, and we would get x to the negative 6, which means that would have to go to the denominator because it's negative. Or we can do another way where we cancel out the one on whatever the smallest one is. So the one on top is the smallest, that becomes a 1. Then we take the denominator on bottom and we subtract the exponent that was on top. So 10 minus 4, we get x to the 6. So you can look at this two different ways as to how to simplify the variables. So this simplified form is 6 over 7x to the 6. Notice the x to the 6 again is in the denominator, because again when we subtract the top exponent minus the bottom exponent, we do get negative 6. Since x is to the negative 6, that means it would have to go to the denominator to become positive. Or, this was number 1, or you cancel out the smaller variable with the smallest exponent, put a 1 there, and then take the large exponent and subtract the bottom exponent, wherever that large exponent is. So that large exponent is on the bottom, so 10 minus 4 is x to the 6 on the bottom. So there's two different ways that you can show how to simplify variables. All right, so now let's look at how to state any excluded values. So when we state excluded values, what we're going to do is look at the denominator. So we're looking for variables that are in the denominator, in the original denominator. So in the original denominator is x to the 10th. So x to the 10th, we're going to set it equal to 0. Well, it doesn't matter what x to the 10th, what this exponent is, I guess I could say. All we want to know is what x is. So x is 0. So x can't be anything else but 0. So 0 to the 10th power, that would be 0. So that's our excluded value. So this is basically what x cannot equal. X cannot equal 0. So this is one of the easier excluded values to find, but you just got to remember it doesn't matter what this exponent is. X to the first power is what we're solving for. So we're just looking for what x to the first power cannot equal. So that's how you do that one. All right, number 2. So this time we have a binomial in the numerator and a binomial in the denominator. When you have a binomial or a trinomial, you need to try to factor. So for 2p minus 20, the greatest common factor is 2. So I'm going to factor out 2 from just the numerator, and I get p minus 10. In the denominator, 8 is the greatest common factor. So factor out 8, which means we're just dividing both terms by 8, and we get p minus 10. So remember to factor first before you start to cancel. Okay, factor first. So you can cancel out binomials that are identical. So p minus 10 and p minus 10 cancels out. When they cancel out, they become 1s. So canceling out does not mean become 0, it means it becomes 1. So now I have on top 2 times 1 and on bottom 8 times 1. Well, this will also factor. This is a numerical fraction, not factor, cancel, or reduce. They will both divide by 2. So now my simplified answer is 1/4. So the simplified form of 2p minus 20 over 8p minus 80 is 1/4. Now let's look at how to find the excluded values. So we go back to, what I go back to on this, I go back to the original, is I go to the factored form. So look at the factored form. Before I canceled out the p minus 10s, we had 8 and then p minus 10 in the denominator. Now, 8 will never equal 0, okay? So we don't even have to worry about that. We don't look at the factors that don't have the variable. So we're only looking at the factors that have a variable. So this is the factor that has a variable. Set it equal to 0 and solve. So this is actually the excluded value for p, because if p were 10, then this would be an undefined expression. Okay. All right, number 3. Again, we have a binomial over a binomial. So in the numerator, I factor out the greatest common factor, which is a 2. So divide both of these by 2, and I get t minus 4 in parentheses. Now, this binomial is actually the difference of 2 squares. So when we have the difference of squares, they will factor into conjugates. T plus 4, t minus 4. So remember, we have to have different signs because that's a negative 16 there. And we don't have a middle term, so that means when I do FOIL for t plus 4, t minus 4, I'm going to get a 0 for a middle term. All right, so now that we've factored, now we can cancel out identical binomials. So t minus 4 will cancel out this t minus 4 on the bottom. So now I have t2 over t plus 4. So that is what this reduces to in lowest terms. Now, for the excluded values, okay? So we're looking for the excluded values. We go to where, again, the factored form, before we canceled, and this time we have 2 factors that have t, or have a variable as part of their factors. So t plus 4 equals 0 and t minus 4 equals 0. So we solve each for t, and we have 2 excluded values, negative 4 and positive 4. So these are the values that t cannot be equal to, or this will be an excluded, an undefined expression. All right, number 4. This time we have 2 trinomials. We have a trinomial in the numerator and we have a trinomial in the denominator. So we have learned how to factor these. This is a real simple guess and check. We want the factors of the last term that add up to be the middle term. So this will be y minus 5, y minus 1, over y minus 6, y minus 1. Now, if you want to, you can actually, at this point, find your excluded values. It's up to you. Just don't forget, you have to go back to before you actually cancel for your excluded values anyway. So my excluded values are 6 and positive 1. So we'll enter that last. Now let's cancel. So y minus 1 cancels y minus 1. So the simplified form is y minus 5 over y minus 6. The excluded values are 6 and 1, or 1 and 6. It doesn't really matter the order that you put them in. All right. Number 5, we have a trinomial over a binomial. Again, anytime you have a binomial or a trinomial or any kind of polynomial with more than 3 terms, or more than 2 terms, more than 1 term, then you need to factor. So the numerator will factor into x minus 1 squared. I'm going to go ahead and write it out as x minus 1, x minus 1. And then the denominator, I can factor out a 2. Now, again, when you want to do the excluded values, you can. You're only looking at the denominator where the variable terms are. So this is the one that has a variable in it. Don't just ignore the 2, because the 2 doesn't have a variable in it. So x minus 1, set it equal to 0. So my excluded value is x equals 1. And come back over here. Now you have x minus 1 on top. There's 2 x minus 1s on top, but there's only 1 x minus 1 on bottom. You can only cancel 1 for 1. So x minus 1 on top cancels 1 x minus 1 on cancels x minus 1 on the bottom. So there's still an x minus 1 left on top, and there's a 2 on the bottom. So the simplified form is x minus 1 over 2. The excluded values are, well, in this case, it's just 1. All right, one more. Number 6, I have a binomial on top and a monomial on bottom. On top, again, anytime you have a binomial, trinomial, polynomials that have more than 1 term, then I want to look to see if I can factor. So in the numerator, I can factor out the greatest common factor, which is 4z. So remember, when you divide both terms by 4z, you're reducing the coefficients and you're subtracting the exponents. So I'm going to get z squared plus 7 over z to the 5th. Okay, so one of the methods I showed you for monomials is to cancel or subtract. Notice that only this monomial will reduce this monomial. The binomial right here cannot be reduced or canceled by another monomial. So z squared plus 7 is going to say z squared plus 7. But 4z over z to the 5th, the z's, the z portions of those 2 monomials will reduce each other. Okay, so I'm going to show you the method, that second method I showed you. And the z to the 1st is smaller than the z to the 5th. So I'm going to cancel out the z to the 1st. That's actually a 1, so that's 4 times 1 on top, which is still 4. Okay, on the bottom, I'm going to subtract the exponent from the top that I just canceled out. So that's a 1. So now that will be z to the 4th. So the simplified form is 4 parentheses z squared plus 7 over z to the 4th. Now, for the excluded value, go back to before we actually subtracted. It really doesn't matter. There's only one variable term. There's only one monomial, or that's the same thing, a monomial in the denominator. So z to the 5th cannot equal 0. So I don't want to know what z to the 5th. I just want to know what z cannot equal. So z, just z to the 1st, cannot equal 0. All right, so those are the homework examples for 11.1, homework number 1.